combining two different parts of her career and her life and kind of showing it in one thing. Let's give a round of applause.
Hi, everyone. You hear me okay? Yeah, I'm going to try to stand away from the very bright light. So like you said, I'm a Ph.D. student here in New York City at the CUNY Graduate Center, which is part of the City University of New York. And I'm actually in the linguistics department. So I thought I'd give like a little background about me before I get into the talk so you guys can see how I got interested in this. So I'm in the linguistics department, so my predominant interest has always been language. I got into grad school because I wanted to learn how humans process language, understand it, produce it. But what I always found so fascinating about language was its ability to tell you a lot about an individual beyond just what the message is meant to communicate, right? You can learn about a person's personality, their emotional state, their mental state, where they're from, possibly their age, depending on what references they make, right? You can learn a lot about a person just from how they speak. So in my first semester as a graduate student, about 5 years now ago, I took a course on computational linguistics. And it was the first time I ever heard of natural language processing. And I was like mind blown. I was like, this is so cool, right? It's linguistics for computers, which is just amazing, right? You're getting the computer to try to produce, understand, process language like a human does. So that was it. I was like, okay, this is my field. And I went with it. The only problem was I didn't know how to code. I didn't know anything about natural language processing or machine learning. So I spent about the first 2.5 to 3 years of my PhD learning about machine learning, learning how to code, teaching myself using kind of like online videos, and I made a lot of good friends with computer scientists and picked their brains a lot to just get the skills to begin to conduct the research that I wanted to conduct. So about 2.5 years ago, when I finally felt like I was ready to start doing some serious research, I started thinking about what I wanted my research topic to be. And everyone says pick a topic that you're super passionate about, right, for your dissertation, because you're kind of stuck with it for many years and you spend a lot of time with it. So I really wanted to pick something that I love, and not in like the nerdy, like academic, like I love this topic, but something that like as a human, as a person, that meant a lot to me. So I started thinking about like, okay, what do I love? And I was like, my parents, my loved ones, my dog, right? And like none of those seemed like a realistic dissertation topic. So I started thinking about like, where do I spend most of my time? And growing up, I was an athlete, I was a gymnast, I was a competitive cheerleader in college, which I do consider a sport, one of those people. And then like since then, I've gotten into like weightlifting, and I like to call myself an Olympic weightlifter now. So health has always been really important to me. So I was like, okay, health, tech, language, like how can I make this all work? And I started looking at existing tech. And the industry right now for physical health is huge, right? It's booming, right? Everyone's tracking how many steps or how many calories they eat a day, right? There's wearables, there's phone apps, right? Like they're really tracking your physical health, but I didn't really see anything for mental health. And your advisor tells you all the time, like, what's novel about your topic? What's novel, right? So you want to do something as a PhD student that's different. So I was like, okay, well, there's this whole industry that's really not being focused on. So that's how I got into the literature, the linguistic literature, actually, on the relationship between language and depression. And I was like, okay, well, this is a great topic, and I went with it. And the kind of last piece of the puzzle is I'm a research fellow at the Futures Initiative. That's what FI stands for. That's a really cool program at the GC, the Graduate Center, that focuses on kind of restructuring higher education, making it more equal, accessible, and really focuses on open source, the open source community. So I knew that I wanted the last piece of the puzzle of my dissertation to be a contribution to open source. So that's kind of what I'm going to talk about today. So a little background on depression, right? So let's just start with like the typical clinical definition, right? So a person is clinically depressed when they experience a depressed mood and or diminished interest and pleasure in combination with 4 or more of the following symptoms. Things like unintentional weight loss, gain, fatigue, feelings of worthlessness. Everyone's like, oh my God, I'm depressed, right? Like I experience all this, all the time, right? So it reaches the level of a clinical illness when you experience these symptoms for 2 weeks or more. So, okay, why should we care, right? So about 350 million people in the world suffer from depression. So if we look at data in the United States alone, this is data from, I think, 2013. This graph and the next one are actually from a great keynote talk by Tom Insel. So if you Google Tom Insel and depression, it's like one of the first videos that pops up. He gave the keynote address at the Computing and Mental Health workshop last year. So if we look at sources of disability, mental disorders confer the largest source of disability in the United States. So it's affecting the largest group of people. And then if we look at that, when we plot it against age, here the line in red is, again, mental disorders. We see that the age of onset is much earlier than every other group of disorders, right? So it's affecting a huge number of people, and it's affecting young people. There's also some serious consequences, right? About 9 in 10 people who died by suicide were diagnosed with a mental disorder, right? So it's a serious problem, and it's really hard to diagnose, right? We look at the profile for it. 2 people can go into an office exhibiting completely different symptoms and both be diagnosed with the same disorder. So it's a really hard disorder to diagnose. So here's where kind of tech comes in. Like, we can help, right? So here's a great project. I'm going to just show you a little clip.
It's time for your therapy session. Sit facing your screen. This avatar is a virtual therapist who's going to ask you the usual questions. How are you feeling today? When was the last time you felt really happy? Would you like to say more about that? And so on. The therapist is called SimSensei, a system that was developed by Louis-Philippe Morancy and a team of researchers at the University of Southern California. Behind the avatar is a powerful program that analyzes the subject's non-verbal communication, from facial expression, eye movements and gestures, to intonation and posture. All of these signs say a lot about their emotional state. This real-time analysis not only lets the system adapt its questions to the subject, but can also spot anxiety or even depression. Our virtual therapist is a state-of-the-art tool that healthcare providers can use for screening and monitoring patients. So, how are you feeling today?
Okay, so I picked that video because it was the shortest. It's also, there's also some other great videos about SimSensei where you can see her like interacting with patients and whatnot. I know that was kind of the most like infomercial type video. The project's really interesting. It's at USC, Institute for Creative Technologies. I got the opportunity to intern there last year. And they've built this virtual human. And you can kind of think of her and the project in like 3 groups, right? You have this first group where they're working on building a virtual human, right? They're AI to do this automated interview, right? It's a scalable solution for people who can't get to a clinician or live in remote areas, or there's just not enough people to help the people in need, right? So that's kind of step 1. The second step is kind of getting the person to feel comfortable, right? And having the virtual avatar kind of adapt the behavior so that it simulates a real life conversation. And there's people studying that as well. And then there's this kind of like third part, right? Now you have all this data, right? You have video, you have audio, you have this whole conversation. What can we do with this data, right? And that is the project that I'm involved in, for my dissertation, right? So far, what they've done with SimSensei is they've mostly looked at video and audio. And they've looked at facial characteristics, gestures, and acoustic properties to try to use those behaviors to make automated assessments about mental health, including things like anxiety, PTSD, and depression. So me as the linguist, when I came onto the project, I was like, well, we're not looking at language, right? We're not looking at the words they're using. We're not looking at their syntax, right? And if you talk to any clinician, right, language, that interview, what the person is saying is a huge part of that diagnosis. So for my dissertation project, I'm building a multimodal system. So I'm taking kind of the system they've already built and then just adding the language component. So now you have a multimodal system that's across video, audio, and language. So here's kind of what the pipeline would look like for the entire project, right? You have the first stage, which is data collection. So that's the SimSensei data set of the interviews. It's about 700 people being interviewed by SimSensei. And then you have the second stage, which is feature engineering. And for people who don't know what that is, it's basically taking that raw data and converting it into something that the computer can understand and converting it into something that's meaningful. So for depression, right, we want to create representations that can capture that, right, capture symptoms of depression. So that's what I'm going to talk about mostly for today. And then you kind of have like the last step, which is the machine learning. So now you have the representation, you give it to the computer, and you train it to learn to make the right prediction. For my dissertation, I'm working on this tool, which is I call OpenMmm, and it does not, so my name is Michelle Morales. It does not stand for my initials, although I've been asked that a lot. It stands for multimodal. Right now in depression research, there's, the predominant interest is looking at speech and looking at visual cues, and not really looking across modalities, because people tend to focus on a specific modality, right? You're either like a video person, or you're a social signal processing person, or you're a linguist, right? And you're working mostly with text. So right now, there really isn't any tool out there that any researcher can use for free that is working across modalities. So what I've decided to do is I wanted to take 2 projects that are really good, that have had a lot of success in building classification systems for depression, and I wanted to add on the linguistic component. So this is what the pipeline looks like. The idea is you just give it a video, right? That's the only thing you need to give the system for input, and it does all the processing for you. So OpenFace is an open source tool, it's in your little book, that does feature extraction for video. So this will extract representations for your facial characteristics, your gesture, your posture, your head movement, things like that. So that's the first step. And this could be really useful in capturing smiles, frowns, so things like that, which could be useful for depression, right? The second step is, okay, now you have video, let's convert it to audio. The tool does that for you. And then let's extract meaningful things about the acoustic signal. CoverRep is an open source tool that does that for you already. So in my tool, I incorporated that as well. So now you have things about how loud they're talking, how fast, how slow, right? Which can also be useful in capturing certain things about depression, like the tendency to talk really slow or be really sad, right? And then the last component is now that we have audio, we can get at that language and we can get at it in an automated way. We no longer need to transcribe things by hand, right? You have Siri, speech to text, right? So the tool uses the Watson API for English and the Google API for German and Spanish. So it supports 3 languages right now to get a transcript, right? And here's where my kind of code comes into play, right? And it's code to do linguistic analysis. So it parses your sentence for you to get at how complex, to get at the part of speech tags you're using, to get at what type of words you're using. So you can get a sense of what the person is talking about. And you can kind of think of these as like frequencies of how often you say this word or that word. And then the tool combines it in a way so that you have one nice kind of like Excel file of data to then feed into the detection system. It's freely available on my GitHub page. You know, how well does this work? Now that we have all these features, right, monitoring the person's behavior, can we use it to make a prediction about their mental health, right? There was a really interesting study. This links to it. Email me if you want to read the study. That they did like a meta-analysis of about 40 different studies that looked at the general doctor and how well they were able to make a prediction for depression, a diagnosis, without any sort of diagnostic tool, right? So they didn't have a survey or a structured interview. They didn't have access to any of that. It was just that person listening to the person and making a prediction. And humans were only able to make the right diagnosis 47.3% of the time. So my tool, I just got some nice results, which was great to include them here. Using data, using multimodal data, multimodal features, and using an algorithm to train the computer to learn, it was able to make it the right prediction 76% of the time for like a binary depressed or not depressed. And this was on a very small data set. So I just want to make a note that this is a work in progress, and I am not an engineer or a developer. I don't have a major in computer science. I'm just really passionate about language and exercise and health, and I wanted to build a tool that can make a difference. So keep that in mind when you look at my GitHub page. The person, the Jessica, I think, who gave the bug talk made me reevaluate my documentation. So I am working on a wiki now to explain how to use everything. And I just want to point out that like all of that part, all of those tools are already out there, right? All I did was this part, right? I worked on code that I was really interested in about linguistics. And I did some fusion. I ran these tools for you so you didn't have to do it, but to get a nice result that could be used for another task. So don't be afraid to play around with other existing tools. You don't have to reinvent the wheel. You can just make that better by building right on top of it. So in case you're like super confused about what feature extraction is and like I made no sense, I wanted to give you an example of kind of what it does. So this is a portion of the tool, right? This isn't, I incorporate OpenFace, so this does the visual feature extraction for you. So this should work. Okay, so this is me acting really well. So I'm happy and I'm sad, right? And this is OpenFace, so you can kind of get a sense of me moving my head, right? So you can see what the computer is doing, right? It's tracking my eye gaze. It's tracking, I think I'm standing outside the box I'm allowed to be in. It's tracking my head movement, right? My lips. And then it takes that, and then you get an Excel file, right? Where it tells you what time you're at. It tells you where your gaze was. And then these numbers get fed into the algorithm that then makes the prediction. This is a hard problem, right? You have a lot of people to convince to get these sorts of tools to be used by clinicians. It's an interdisciplinary problem, so you have a lot of people to convince. Computer scientists, you need developers, you need psychologists, linguists, you need all these people to collaborate to have a successful system. But I'm hoping that we'll soon see more of diagnostic tools used by clinicians that use technology, virtual assistants being more kind of mental health aware. We can use these as companions, more things like SimSensei, and there's a lot of ethical things to think about in terms of privacy and safety, and I think people are beginning to discuss these things, which is good. I just wanted to end with, feel free to just jump right in. There's like a lot of existing data sets that are publicly available for depression. So the DAC, the second one, is SimSensei. So that is that corpus that I was talking about. It's a portion of it, but you can start looking at the data and playing around with it. This first one is from another publicly available data set. That one's in German. It's videos of people, and then there's mental health assessments that go along with that. And the tools that I mentioned, including my own, and then for anyone who wants to check out more of I do all my machine learning in scikit-learn, which is a great Python library for people getting started with machine learning. Their documentation is really good. So if you have any questions, feel free to email me or reach out to me on Twitter. And I'd just like to thank all the Codeland organizers. I feel super grateful to be here with this amazing lineup of speakers. So thank you.